Hello everyone, welcome to Unacademy, the number one learning app in India that made learning easy for all the students. So thank you for joining everyone, and I will wait couple of minutes till all the joiners come for live as soon as possible. So this is all about combination of capacitors from the unit current electricity. The beneficiaries. Before going for the session, we will look for the what are the beneficiary we give for the students if you subscribe for Unacademy Plus. See, we have a lot of beneficiaries for you guys. Like complete syllabus will be covered if you subscribe for Unacademy Plus, and even tips and tricks given by the top educators from the part of Karnataka, and topic-wise practice questions, full length mock test. So these are the beneficiaries what we give for the students if you subscribe for Unacademy Plus. So please subscribe for Unacademy Plus to avail all these beneficiaries, and even use my code RITESHLIVE. So this is my code. If you use this code, you will get 10% of instant discount over the plus subscription, and 1 month plan is like at 2250, and it is only till November 30th. So subscribe as soon as possible. And even we have other plans like uh, we have 1 month plan, we have 6 month plan, and we have 12 month plan. And for those students who are studying in plus 1 class, and for those students we have 24 month of plan also. So you can subscribe for whatever the plan best suits for your profile, and even you can use my code to avail better discount over the subscription medias. Okay, so the beneficiaries we give for the students is like premium content at affordable price, structured live courses, quizzes at a regular interval of time for self-analysis, batches for the complete preparation, a test series for DPPS, full-length mocks, etc. with analysis, single subscription for the unlimited access. So these are the lot of beneficiaries we give for the students. So please subscribe for an Academy Plus and use my code RITESH2 RITSHLIVE for getting 10% of instant discount. Okay, so shall we move for the session? So I hope everyone is ready. Okay, so combination of capacitors, so it is very important concept you need to understand, because in the next chapter we have combination of resistors. So it is somewhat similar, but the thing is the equivalent of capacitor and equivalent of resistor is different. That's it. The equations will be vice versa. Okay, so if you study for combination of capacitor, then you can easily understand the uh, concept of what resistors. So this is all about combination of capacitors and resistors. Hello, hi, Suju, hi, Peter, Kirtu. Thank you for joining, Peter. Peter, we had these sessions in our Unacademy platform, and we are recalling it. So if you can join, you can be there till the session ends. Right, you can recall all the things regarding capacitors. Okay, done. See, these are the three capacitors which are in series. You know the equation like 1 by C equivalent for the capacitors which are in series. 1 by C equivalent is 1 by C1 plus 1 by C2 plus 1 by C3, right? For the parallel, it is what C equivalent is equal to C1 plus C2. So this is what combination of capacitors formula for the C equivalent. Okay, so if we have three capacitors of C1, C2, C3, the values they have given like 10 microfarad, right? When they are in series, so what is the value? 10, 10, 10. So when they are series, the equation is this one for series, right? C equivalent will be what? So for C equivalent will be C equivalent is equal to 1 by 10 plus what? 1 by 10 plus 1 by 10 whole inverse. That is nothing but C equivalent, right? We will go for MCQs next. MCQ, multiple choice questions. We will solve this first. Like we will get a 10 by 3 inverse. That is 3 by 10. Okay. So the given figure will now rewrite as, we can rewrite it as, this is the capacitor, and here is another one that is connected to battery, right? Okay. So this is the battery. So V, how much they have given? 500 volt. This is 500 volt, and it is 3 by 10 microfarad, and it is 10 microfarad. See again, these two are in what? These two are in parallel, right? So when they are in parallel, I can rewrite and I will get a equation for parallel. For parallel, this is direct plus. So 3 by 10 plus 10, right? 10, 3 plus 30, 10 into 3, right? So we will get 33 divided by 10. Is it right or wrong? 10, okay, 10, okay. So 3, and we have 10 here. Okay, 10 into 10, right? Right or wrong? So what is the value? Here you get, or else you can directly calculate it if you have some confusions like that. Then you can directly using your calc, you can calculate for that. Okay, let me calculate. Leave, it is not opening. So the term is 3 by 10. Oh, not 3 by 10. Sorry, right. So this is not 3 by 10. When you go on inversing, you will get value of what? 10 by 3, right? Then here, let me erase this. Okay, so this is 10 by 3. So ಆರಾಮದಲ್ಲಿ ನೋಡಿ ಮಾಡಿ. So confusion ಆಗಲಿಕ್ಕೆ ಹೋಗಬೇಡಿ. So when you do confusions, then we will have these type of complications. 10 by 3. We have 3 here. 10 plus 3 into 10, that is 30. Right? So I get value of 30 by 3, that is C equivalent. Okay? So this is 40 by 3. And we have 500 volt. Okay? What I need to get? Okay, C equivalent I anyhow got. Then I need to get mm, charges on each capacitor. Let me try. Okay, how we get? So that is Q net. Q net is what? When a voltage of 500 volt is applied, then Q net is Q is equal to CV. Q is equal to CV. C how much we got? 40 by 3 into V how much we got? C into V, anyhow we know 500, right? So that is nothing but 5 for the 20,000 divided by 3. So that is microcoulomb. So this is Q net. Okay, Q net over here and here. So will be different, right? When they are in parallel. Okay, so Q will move in this direction, which is same all over the capacitors, three capacitors, right? So you know the theory. So that I can directly write Q1 is equal to how much? 2000 divided by 3 or what? No, I can't write because Q will be different here and here. Q1 and Q2 you will get. Alright. So this is wrong. So I need to do voltage line for this type of. So we had this one. Okay. So you draw the voltage line because when capacitors are in series capacitors, series circuit, the voltages will be same, right? So what I do is, which is the best color, okay. So I will draw a voltage line here, V and V. Okay. So this is the V, it is coming here. So V is equal to 500 and here also 500. Voltages will be same. Okay. Or else you can do like what? How can you find Q is equal to CV? In finding that also you will get same value. That is Q is how much I got. Q net how much I got? See here Q net 2000 20,000 divided by, see here 20,000 divided by 3, that is 20,000 divided by 3 into uh, okay, divide Q divided by C. See how much I got? 40 divided by 3. So that is nothing but 3 divided by 40. 3 get cancelled. 40 500 right? Same value. So okay, so 500 volt both here. So I need to get I value, right? Okay, so what is I value? V is equal, sorry, Q value, Q is equal to C into V, that is C how much? 10 microfarad, 10 into V how much? 500. So the value is 5000 microcoulombs. So that is Q over which capacitor? Over this capacitor, right? That is Q4. Okay, I got Q4, I will highlight this. Okay, done. Similarly, you go for another, like you go for here, okay, 500 into V, that is 500 into C how much? 3 by 10. 10 ones are 10, 5s are 50, 10 5s are 50, 50. Okay, 50 by 150. 150 micro coulombs I get. But this is combination of what? This is combination of all three resistors. So that is I can directly write Q1 will be 500 divided by 3, right? How much I got? Okay, 150. So okay. So this is 150 microcoulomb. Q2 is equal to 150 microcoulomb, and even Q3 is equal to 150 microcoulomb. Okay. So this is the value which I got. So charges on each capacitor, right? Okay. Similarly, you can get the value for this charges over all the capacitors. First, what you do is when they have not given any naming for the capacitor, then you only name it C1 and take this as C2 and take this as C3. Okay. When these two are in series, what is the value when those two are, that is 1 by 200 plus 1 by 200 picofarad whole inverse. That is nothing but C equivalent, right? When they are in series. So you will get some value, that is 100 maybe, I guess. Okay, that is 100. 100 what? Picofarad. Again, these two are in parallel. When they are in parallel, what? Direct plus. So 100 plus 100, that is 200. Okay, 200 picofarad. But there is another one. So which is connected to 100 picofarad. So but it is what? In single path. Alright? Single path means again you need to do 1 by 200 plus 1 by 100. Right? So that is 200, 1, and 2. That is 3 by 200. You need to inverse. That is 200 divided by 3. So it is nothing but C equivalent. Very simple. So you can do without any hesitations, right? Simple. Okay. So the thing is, okay. So the thing is, you need to find Q value. Then you need to do simple. What you need to do? You need to do voltage line here. So V across here will be 100. Why? Because it is parallel, so V will be same. 100 is the supply voltage here, right? Okay, sorry. So it is not the voltage, right? It is not the voltage. So here is the supply. Okay. You need to draw here. Okay. So that is V is equal to 300. And here also V is equal to 300. Similarly, you need to do. Okay. This is all about combination of capacitors. We will go for MCQs right now. Okay. One second. Yes. MCQ starts from here. The condensers of capacitor C1 and C2 are connected in parallel when the equivalent capacitance is, then the equivalent capacitance is what? So you can comment there regarding the options. Condensers of two capacitors which are in parallel. When they are in parallel, like this, right? You can comment there regarding the options. Okay. So these are in parallel like C1, C2. When these two are in parallel, what is the equivalent capacitance? You know the formula? When it is in parallel, Q, how we derived Q is equal to it, law of conservation, Q2, right? Yashasvi, hi, are you there? In hi, Lane. Thank you for joining. Obedient student actually. Dhananjay. Super, are you there? Super, great. So A is the right answer. When they are in parallel, you know that, right? How to derive it? Hmm? Uh, Q is equal to CV. That CV is equal to voltage will be same. So C1V plus C2V we got. So we directly write this is nothing but C equivalent. V get cancelled. Remaining is C equivalent is equal to C1 plus C2. So this is the derivation actually. Okay. So the right answer is A. High. Super. Next, the capacitor of capacitance 4 microfarad and 6 microfarad are connected in series. A potential difference of 500 volts applied to the outer plates of the two capacitor system. Then the charge on each capacitor is what? Two capacitors are capacitance. Hi Dhananjay, Dhanne. Thank you for joining actually. Sorry, forgot to tell. So these two are connected in series. Two capacitors, right? Then they are connected to one battery. Two capacitors of 4 microfarad and another capacitor of 6 microfarad and connected to a battery of 500 volts. Okay, so you need to find the charges on each capacitor. Andre, here and here, what is the charge? Okay, so first what you need to do, you need to get Q net value. Okay, charges over two capacitors which are in series will be same. When capacitors are in series, then charges over both the capacitors will be same. When they are in parallel, then that will be different. But you find the Q net here, Q net value, that value will be the same value. It is same here and here also, right? Okay, so Q is equal to CV, that is C equivalent into V is 500. C equivalent when they are in series, that is 1 by 4 plus 1 by 6. So what is the value? Can you comment there? Anyone? That is 4 and 6. 12 is the LCM. 3 plus 2, that is 5 by 12. Inverse 12 by 5. Super. Um, but mistake wrong. Yashasvi, try to answer again. 12 by 5, that is 12 by 5 into 500. Oh, ಎರಡು correct ಉಂಟು. Sorry. Option. Both are same. Okay. So this is 200. Okay. So the right option is 1200. Right? 100, that is 1200 microfarad. Simple. Next, three capacitors are connected to DC source of 100 volts as shown in the figure, adjoining figure. Okay, if the charge accumulated on the plate C1, C2, C3 are QA, QB, QD, QE, QF, etc. Okay. Then which condition is satisfied? Simple, direct ಆಗಿ ಹೇಳ್ಬೋದು. ಯಶಸ್ವಿ, which is the right answer? Direct, ನೋಡಿಲ್ಲಿ. Charges on each capacitors will be same when they are in series. If this is Q net, charges over Q1, Q2, Q3 will be same. So which is the option? Option number D is the right answer. Alright? So Q plus, so total ಈ ತರ ಬರ್ಲಿಕ್ಕೆ ಚಾನ್ಸ್ ಇಲ್ಲ. Okay, all are similar, all are same here. Okay, it is slightly blur. Okay, no issues. Okay, then this is okay. Dhananjay, Yashasvi, good. Next one, three capacitors of each capacitance, 1 microfarad. Let me change the quality. Three capacitors of each capacitance, 1 microfarad are connected in parallel. Three capacitors they have given. Okay. Dhananjay, observe here, three capacitors they have given, which are in parallel. Done. Now this combination is connected to the fourth capacitance of 1 microfarad again. That is connected in series. So this is the system what they have given, what they have asked in the question, right? Okay. So what are the capacitors of 1 microfarad here? Given here is also 1 microfarad, 1 microfarad, and it is connected to a fourth capacitance of 1 microfarad. So voltage they have not given, but you need to find the resultant capacitance. C equivalent is how much? Can you please? So which is the right option? So these three are in series. These three are in parallel. Yashasvi. Good Yashasvi. Super. So the right answer is ಗೊತ್ತಿದೆಯಲ್ಲ, you will get when they are in parallel direct plus, that is 3, then connected series, that is 1 by 3 plus 1 by 1 whole inverse, right? So super Dhananjay. So you know the concept then, Dhananjay, right? So this is 3, 1 plus 3, that is 4 by 3 inverse. So the answer is 3 by 4. So equivalent capacitance is D. Right. Next. 5 capacitors of 10 microfarad capacity each are connected to a DC potential of 100 volt as shown in the figure. The equivalent capacitance between A and B is what? See, this is what? This is a type of Wheatstone bridge. Wheatstone bridge. You know that regarding Wheatstone bridge? See, when the path of current is opposite to each other, then in that line circuit, the current I will be zero. Okay. See here, current voltage here, then current will pass in this direction here, and then it will divert in two paths. Again here, and observe here, it will divert in these two positions, right? And similarly here also in these two positions. But in this circuit, in this line, it is opposite to each other. I is opposite to each other, right? That is nothing but net current will be zero in this circuit. So neglect this. So only remaining is what? Only remaining is these four. Okay. So and try to get the answer. So these two are in ಇದನ್ನು neglect ಮಾಡಿ ಇದು ಬೇಡ ನಮಗೆ Wheatstone bridge ಯಶಸ್ವಿ again fifth one. These two are in series, that is 1 by 10 plus 1 by 10, and here also 1 by 10. Super Dhananjay. Dhananjay, where are you from? Actually, you are responding well. Thank you for your response. Dhananjay, where are you from? ಎಲ್ಲಿಂದ ನೀವು? ಊರು ಯಾವುದು? Next, three capacitors of capacitance 3 microfarad, 9 microfarad, and 18 microfarad are Belgaum. Wow, super. 3 microfarad, 9 microfarad, 18 microfarad are connected once in series and another time in parallel. ಗೊತ್ತು ಬೆಳಗಾಂ ನಮ್ದು ಯೂನಿವರ್ಸಿಟಿ ಅಲ್ಲೇ ಇರೋದಲ್ಲ ಇಂಜಿನಿಯರಿಂಗ್ ಯೂನಿವರ್ಸಿಟಿ ಬಿ ಟಿ ಯು ನಾವು ಕರ್ನಾಟಕದವರೇ ನಿಮ್ಮದು ಒಂದೆರಡು ಸ್ಟೂಡೆಂಟ್ಸ್ ಇದ್ದಾರೆ ನನಗೆ 2-3 ಜನ ಅನ್ಅಕಾಡೆಮಿ ಪ್ಲಾಟ್ಫಾರ್ಮಿಗೆ ಬರ್ತಾರೆ ನಾರ್ಮಲ್ ಕ್ಲಾಸಿಗೆ ಬೆಳಗಾಂ ಅವರೇ 3 to 4 ಮೆಂಬರ್ಸ್ ನಿಮ್ಮದು ನಂಬರ್ ಡ್ರಾಪ್ ಮಾಡಿದರೆ ಐ ಕ್ಯಾನ್ ಕಾಲ್ ಯು ಆಫ್ಟರ್ ದ ಸೆಷನ್ ಧನಂಜಯ್ ಸೊ ಯಾವ್ದಾದ್ರು ಡೌಟ್ಸ್ ಇದ್ರೆ ಎಲ್ಲ ಕ್ಲಿಯರ್ ಮಾಡ್ಬೋದು. Okay, so see here, three capacitors of capacitance 3 microfarad, 9 microfarad, and 18 microfarad are connected in series, another time in parallel. The ratio of equivalent capacitance between CS and CP. Dhananjay, drop your number there so that I can call you after the session and I will help you regarding the subject for sure, 100%. ನೋಡಿ ಇದು ಮೂರು ಕ್ಯಾಪಾಸಿಟರ್ಸ್ ಇದೆ 3 capacitors 9 capacitors and 18 capacitors. So these 3 capacitors are first connected in series. Okay, series andre ee tara, okay, right, you know that. Then they have connected in parallel like this, and you need to get the ratio of CS and CP. So what is the ratio? When they are connected, that is 3, 9, 18. I mean, you will get value of 1 by 3 plus 1 by 18 plus 1 by 9 whole inverse, right? And similarly here 3, 9 and 18 direct plus, that is 18 plus 9, 27, 27 plus 3, that is 30. Okay, CP value you got 30. And here how much you will get? 3, 18 and 9. ಯಶಸ್ವಿ ಎಷ್ಟು ಸಿಕ್ತು 18 ಅಲ್ವಾ 3 3 3s are 3 6 are 18 1 9 2s are, so you will get 6 9 by 18 inverse you need to do 2s are, that means 2 value get, so it is 2, so 2 1s are 2 15s are, the answer is 1 by 50, 1 is to 15. So option number A is right. So hope you understood, my dear. Alright, cheers. Next. Super, Dhananjay. 4 condensers of each capacity, 4 microfarad are connected as shown in the figure. So Vp and okay, voltage difference across these two Hi Tashin, across these two is what? Okay, that is they have given for 15 volts. 4 conductor, okay, 4 microfarad, all the capacitors having, right? So energy stored. For energy stored, you have U is equal to half CV square. Okay. So V you know, C you don't know. So you need to find C value. C is nothing but C equivalent. C equivalent of this circuit is what? Seventh one. When they are in series, it is direct plus, that is 8. Then they have connected to 4. Again they have connected to some 4. So after when they are in series, 1 by 4 plus 1 by 8 plus 1 by 4. So whole inverse, alright. So 4, 2 plus 1 plus 2, whole inverse. You will get 8. How much? What is the value? Dhananjay, Tashin, SSP? Super. So the right answer is 1800. Great. So that is 2, 5. I need to inverse, that is 5, 8 by 5. Alright. Okay, 8 by 5 is the, that is half into 8 by 5 into b square, that is 15 square. So when you do the calculation you will get a value of 1800x. Okay. So next, two capacitors each of 1 microfarad capacitance are connected parallel are then charged by 200 volts DC supply. The total energy in their charges are what? Connected in parallel. Two capacitors are connected in parallel. Okay, like this, and it is then charged by a DC supply for voltage 200 volts, and this is 1 microfarad and it is 1 microfarad, right? So what you need, the total energy in their charges, okay, that is half, again half CV square. So how much you get? That is nothing but half into C, how much you need to calculate here, and V value they have given. Okay, so the right answer is great, Dhananjay, Yashasvi Rao, super. C is the right answer. Thank you. Next, the circuit diagram shown in the adjoining figure, the resultant capacitance between B and Q is what? Between P and Q is how much? First, these two are in parallel. Okay, when they are in parallel, direct plus 5 microfarad. When they are in series, okay, then circuit will be like this. Okay, so that is 12, and here it is 5, here it is 20 microfarad, and you will get resultant equivalent. Sorry, this is capacitance, right? Not a resistance. C equivalent is 1 by 12 plus 1 by 5 plus 1 by 20 whole inverse. So the answer is the ninth one. Common denominator 12, 5 and 20 is to 2, 6 is a 5 is a 10, 2, 3, 5, 5, 3 and 5, right? 15, 30, 60. So common denominator is 60. Oh, 5 plus 10, 12, 3, right? 17, 17 plus 3, 20 divided by 60. That is 21, the 23 is a. So 3 is the C equivalent is 3. Okay, good. Next, two capacitors of capacity C1 and C2 are connected in series and potential difference V is applied across it. Then the potential difference across the C1 is what? So, visible, right? This is V C2 divided by C1. Okay? Yes. So, option number 10. Two capacitors, sorry, question number 10. Two capacitors of capacity C1 C2 are connected in series. C1 C2. C1 C2 are connected in series, and potential difference of V across this. Okay. Then potential difference across C1 is what? So Q is equal to CV, right? So V is equal to Q by C. Yes, good. C1 ನಲ್ಲಿ V is equal to QC. The option number 10th one. Good. C is the right option. Okay. Next one. The capacitor of 4 microfarad and 6 microfarad are connected in series. The potential difference 500 volts is applied out of plates of the two capacitor system. The potential difference across the plate of 4 microfarad capacitor. Okay. So these two are in series. Bhavana, hi, good evening. Thank you for joining. And it is connected to a voltage difference. How much? 500 volts. Alright. Okay. So this is 4. This is 4. Okay, you need to find potential difference. Okay, this is 6. Sorry. Potential difference across 4 volt. Okay. So how you get Q is equal to CV, and here you need to find V value, right? When they are in series. V is equal to Q. Q net will be same here also. Okay. Q is divided by C. C how much? That is 4. So Q is how much? You will get when they are in series. Series means 1 by 4 plus 1 by 6. Common denominator. Bhavana Yashasvi, which is the right answer. 4 and 6. Common denominator is 12. 3 plus 2, that is 5 by 12. I mean 12 by 5. Inverse you need to do. Okay. 12 by 5. So that is nothing but Q. That is equivalent. Okay. So I need Q. Q is equal to C into V. That is C is 12 divided by 5 into 500. So 5 ones are 5 hundreds are. That is 1200. That is Q. 1200 microcoulombs. Alright. 1200 into divided by 4. 4 ones are 4. 3s are 12. 300. The right option is B. So hope you understood, my dear. Is it right or wrong? Yes, this is right. So thank you for joining everyone, and hope you enjoyed the session. And we recalled around 11 MCQs within a fraction of 30 seconds, and even we have numerically done a problem, an important problem, right? So thank you for joining. Thank you so much, and we will meet you all again on Monday over YouTube, and then on Unacademy platform you can meet me daily at 6 p.m. So we are doing resistors there, combination of resistors. You can come for Unacademy platform too. So there my profile name is Ritesh NM Physics. So you can follow there, and you can get the daily updates by following me there. And daily at the 6 p.m. we have the session or physics. So we are on resistors. So this is all about recalling of capacitors in quick session. So you can follow me there, and we will meet you all again on YouTube platform on Monday. That is all about veterinary colleges all over Karnataka. So whatever the veterinary colleges and even dairy colleges, dairy technology, and even for food technology, what are the colleges available? And over Tuesday we will continue this capacitance. Okay. So thank you so much for joining everyone. Love you all. Have a great time and good night. Take care.